and here I simplify the problem statement. So as you see in the image, we are given a series of balloons with colors. Now, how much time does it require, minimal time, to remove a balloon with adjacent colors? If we spot two adjacent balloons with same colors, we have to remove one of them. But here the condition is it must require the minimal time possible. Now I will switch on to my notepad. Before getting into the coding part, let me switch on to the let me have a discussion about the intuition behind solving this problem. Give me a minute. I have to take this input. Now, general intuition for solving this problem. Now they have given a string named colors. For convenience, for better convenience, I convert the string named colors to a character array. Now, say if I convert the string into a character array named array, I get sorry. So this is our character array, and now let's take another array with time as time instead of taking it as needed time for convenience. Here, one of the advantages in this problem is both the character array and the array named time have equal lengths. Now, core condition is if we spot two consecutive balloons with same color, we have to remove one of the balloon, such that it requires minimal time possible. Now, say I fix a pointer I. Now at I equal to 0, I have A, and array of I equal to 0, and at array of 0 I have A, and at time of 0 I have 1. Similarly, at I equal to 1 and at array of 1 I have B. At time of 1 I have 2 seconds. Now for I equal to 2, at array of 2 I have A, and time of 2 equal to 3. Okay, let me just copy paste this and replicate it in every line such that my time is reduced. I can save my time. Now at I equal to 3 and array of 3 I have A, and at time equal to 3 I have 4 seconds, and at I equal to 4 and array of 4 equal to C, and time of 4 equal to 5 seconds. Now when we analyze this entire iterations, when we traverse through the iterations, consecutive iterations, at I equal to 0 I have A, and at I equal to 1 I have B. So these two are different colors. Now increment my pointer. Now at I equal to 2 I have A. At I equal to 1 I have B. Here it's different colors. Now I'll increment my pointer. At I equal to 3 I have A. At I equal to 2 I have A. So I have spotted consecutive balloons with same colors. Now these are the consecutive balloons along with the indices and timestamps where we have spotted the adjacent colors. Now for removing the balloon in index 2, I have to consume 3 seconds. It cost me 3 seconds. For removing the balloon at index 3, it will take 4 seconds. So for efficiency, I have to remove the balloon which takes less time. So which equals 3 seconds. So the overall answer is, overall output is 3 seconds. This is the intuition. Now let's go into programming perspective, programming point of view. This is called greedy approach. The core of greedy approach is we are selecting a choice such that it is optimal at the final solution. It is included in the final optimal solution. Now greedy approach, and I won't reveal the entire code. I will just write a code snippet and explain what it is and why it comes into the picture. And you can keep the colors string as it is, or for your convenience you can convert it into character array. Anything is fine. Now sorry, here I have to return the overall time required for removing a balloon such that there are no adjacent balloons, there are no consecutive balloons with same color. So if the condition inside the if block is satisfied, I will select the balloon which requires least time. And here in intuition we missed a point. I missed a point. Suppose take this case, consider this previous case. Here mat.min is time of 2 comma time of 3, and let me write it, let me expand it further. Now in this example, what is time of 2? It is 3, and time of 3 is 4. When we imply the minimal time required, it returns 3 seconds. Then what about the maximum timestamp? What about the maximum timestamp? We cannot discard it. but we can preserve this maximum timestamp for future uses. It's like, to be simple, I will give you a simple and practical analogy. In a semester exam, usually students attempt the questions which they know first, because they can give their best in the less time, and students give the tougher questions and in the remaining time, so that they can complete the paper in sufficient time and they can maximize their score. So this is the idea behind preserving the maximum timestamp for future iterations. Once I calculate the total, and return total. Now the maximum time which I preserve here will be updated in the next iteration whenever another set of colors, another set of consecutive balloons with same colors are detected, are spotted. So this is greedy approach, the usual greedy approach. Once again, a quick review. Start iterating from left to right. Whenever, keep on iterating for finding two adjacent balloons with same colors. If you spot two adjacent balloons with same colors, we map it to the corresponding timestamp and decide which balloon to remove such that minimal time is needed. But here we preserve the maximum time, because in further iterations, when there is a when there is a timestamp greater than this present max stamp, we can it we we does not have to require to invest maximum time again. This is the first approach, and second approach is a variation of greedy approach, say batch strategy. Now this approach is based on groupings. In the first approach, it's a normal iteration traversing and analyzing two consecutive balloons. But here, let me take an example. Let me take another example test case. Now, the intuition behind this is, what if we group the balloons with same colors? What if we group the balloons which have adjacent same colors? The balloons must be adjacent to each other, the balloons must be consecutively placed, and at the same time same color. Say group 1, the balloon A, the balloon is A, so we skip. And group 2, the balloon is B, we skip it. Now group 3, here there will be a variation because the balloon in the group, uh, the balloon in this place and the balloon adjacent to it have same colors. So include both of them, and the corresponding timestamps are 3, 4. So according to greedy principle, we remove the minimum, we remove the balloon which requires minimum time and preserve the maximum. Remove 3. Now in group 4 we have balloon C and the time is 5. Removing this balloon doesn't contribute much, so the overall time is 3. This is the intuition behind the second approach. And coming to the programming perspective, and a global pointer. In the previous approach, I have used a for loop, but now since it's all about grouping, I will go with while loop. Now I have initiated a variable current to keep a track of the color at the current index. Now declaring max and another while loop. Now the core condition of this approach is this inner while loop gets executed only when the two consecutive balloons have the same color. Now the sum will be whenever you remove a balloon which requires less time, mathematically the time stamp will be added to the sum, time of I. And here after calculating the sum, after calculating the total time for removing the balloon by excluding the minimum, we preserve max by and increment the pointer I for spotting consecutive pairs with same colors. And after this you calculate the overall total time, which is sum minus max. This is overall idea. Now a quick review. Let me take another test case for a clear discussion. So grouping, say group 1 I have initialized, I get 2 balloons placed consecutively with same colors. Now the corresponding timestamps. Now sum of these time intervals is 3. Max is 2. Overall result will be result or total time sum minus max which gives us 1. Here we exclude 1, which is the minimal timestamp, and preserve max. So this is the mathematical expansion of the line of our intuition and understanding. Now group 2, we are done with group 1 by including these two elements, and group 2 is B. The corresponding timestamp is 3. Since it's a group of single element, a single balloon, it doesn't contribute much to the mathematical computation. So sum is 3 and max is also 3, and sum minus max is 0. Now in group 3, again we spot two balloons with same colors. Include these two and the corresponding timestamps 4, 1. The sum of the timestamps is 5, and maximum of these two timestamps is 4, and the result is sum minus max, which is 5 minus 4 equal to 1. And again in the total you add the entire timings of the groups. Here we have got 3 groups, so we add the entire timings, which is 2. And when you verify the output, it's 2. So this is the review of the two methods. And time complexity of method 1 is order of n, and space complexity is order of 1. It's the same for method 2. Method 1 and method 2 are greedy approach, but with a slight variation. In second approach, we consider groups of balloons which are placed consecutively, which have same color. And a practical analogy once again, in end semester examination, students attempt students attempt questions first, the ones which they feel easy, and they are more confident because they can give their maximum output in the questions in less time, and they attempt the harder questions at last because they can utilize more time in thinking and framing their answers. That's all about this greedy approach. Thank you.